Good evening, all of you. Due to some technical problems, it took much time to connect with you. After all, I connect. Yeah, I face some technical problems and now all the things are fine. Uh, Good evening again. Yes, many participant. In the beginning, there was many participant, but now some left. I think they will come back. Sorry for waiting. Okay. So now we are going to start. Good evening. Many participants are there. Samuel, Oy, Arthi Rajan, Ibrahim, Ali, Patience, Ivan. Okay. Thank you. So let's start without any wasting time. We should start now. You can see this is my desktop. You can see my desktop is there. These are the content. This is the MATLAB. Okay. So this presentation I already share with you, and I think you can find in your WhatsApp group. So in this session, we are going to target linear algebra with MATLAB. And in this, we will cover matrix, determinant, and the solutions of a system of equations. Okay. So in this session, there will be the content, a vector product and transpose, creating matrix, adding and subtracting matrix, multiplying matrix, the identity matrix, inverse and determinant of matrix, matrix power and exponential, the canonical delta tensor, and then at the end we will discuss about eigenvalues and eigenvector. So in the next at the end we will target about the various type of applications and like if you are going to solve differential equations and you are want to work on machine learning, deep learning, data science, then these contents are very helpful, very important to solve different type of problems. Because the thing is that all the things which we want to manipulate with the help of MATLAB, all these operations are very important because MATLAB itself work on matrix. When we give any kind of input and we want to work on any input by using MATLAB, and first as soon as we import the information in MATLAB, this always generate a matrix, and on the basis of matrix we do numerous operations on it. Okay. uh, yes, I think I am proper audible to all of you. So you can see, yes, you can see also there will be some vectors like row vector, column vector, length of vector, accessing element of vectors, manipulating elements of vector, transpose of vector, scalar multiplication, and vector addition. So the first thing is how we can write a row vector in MATLAB. Nothing but just like you can see any vector have some element, and when we are going to write any vector in MATLAB, this is very quite simple. A vector of two type, one is row vector and other is column vector, and both can be easily we can enter in the MATLAB. V is equal to V1. Either we can use comma or we can simply give the space. Okay, so at this place we have V1 space V2 and so on Vn. Okay, you can see here there are n elements. Usually these are scalars. These may be real or complex numbers. And if you want to insert this vector in MATLAB, then you can see this is the prompt sign, and either we will insert with the help of comma. You can see V is equal to 1, comma 2, comma 3, comma 4, comma 5. And when you will enter, this will generate a vector, and the corresponding element in the second line, you can see these are the vector which we insert in the MATLAB. And either the another way to write any code for vector, just give the space in the second. You can see V is equal to 1, 2, 3, 4, 5, and when you enter, then you will have the corresponding vector which will be inserted and return the value 1, 2, 3, 4, 5, and so on. See in the MATLAB, because both the things are very important. See in the MATLAB. Okay. Yes. So you can see this is the MATLAB window. You can easily enter either V is equal to, you will use this bracket 1, comma 3, comma 5, comma 7. Okay. And when you will enter, this will return the value, and these are the component of this vector. Or the another way to write any vector in MATLAB is just like 1, comma 3, comma 5, comma 7. And when you will enter, you can see the value of the output of these two vectors are same. Okay, so this is very quite simple to enter any vector in the MATLAB, and after that we can manipulate in many different ways. So now, if you want to write column vector, how we can insert or write a column vector? A column vector have only the rows and one column. Okay, so this is the very simple example of the column vector. And when you will write any vector, then in the case of comma or space, we have to use semicolon. You can see at this place, this is the semicolon. Okay, semicolon we are using for new entry. Okay, and you can see, suppose I have W is equal to, I want to enter any vector 2 semicolon 4 semicolon 6, and when you will enter, you can see the vector has been inserted, and any element and the number of rows or number of column, maybe any component we can have, but this is very quite simple to enter. How we can write row vector or column vector. Okay, now come to the matrix. At this place we have length of vector in MATLAB. Okay, so for to find out the length of any vector, we are using here the simple function is there, length, and we can write in this way. When we assign the value of the vector, then it will return the length of the vector. Okay, see, we have this v vector, and this is the also v, and this is v1. And if you want to find out its length, okay, see, this is the length, and enter, and you can see this will return the length of the vector, because the vector we have only 4 component. Many times when we have very long data in the Excel form, and or in the Excel we have rows and columns are there, and if we are choosing any row vector or in the or any column vector, then we need to check the number of elements. Then in that case we always use this length function, and this will return the number of rows or number of columns or the length of the vector. Very simple to use. Similarly, we have accessing the element of vector in MATLAB, and it is very quite simple. Sometimes we have a very long vector and we want to find out uh, uh, any element in the fourth position or fifth position. We can easily extract that element by using this function. When you will enter this function, it will return the corresponding element of third position. If you have 4, then it will return the fourth element of the vector. See, I am using here, as you know, CLC we are using to clear the command window, and clear is using for clear the workspace. Okay, and CLC. I have a vector v is equal to, you can choose 1, 3, 6, 9, 12, 12. Then I have 13 and 15 and suppress it. Semicolon is used to suppress the statement, and when we will enter, then this will not return the value. So if I want to extract the element which is on the fourth position, you can see fourth element is 9, and when I will extract like in this way, when I enter this command, this will extract the corresponding element from the vector. So, and similarly, if you need to extract the element from third to fifth position, okay, you can easily do in this way, third to fifth position. So this will return the element corresponding to the position, third position, fourth element, fifth element. This will return. You can see the third element is 6, fourth element is 9, and the 12th element is 12. So by using this command, we can easily extract the element from the vector. Okay. Now see, you can see there is one more example element at first position, third position, and fourth position, and it will return the same. Okay, we have already discussed about this. Now we can see manipulating element of vector in MATLAB. We can easily manipulate or assign values to first, third, and fifth element of vector. And the most important thing is that vector on the right must have the same length as the area to which it is assigned. You can see the example at this place. We want to insert the element corresponding to 1, 3, 5. So 3 elements we are going to assign at the 3 positions, and these are the corresponding values. Okay, so first position we have 10, and third position it will return 20, and at the fifth position this will be minus 30. Okay, we can easily insert or assign the values. If you will enter the value in this form, then this will return us the error. Why? Because this element and this element must be equal, only then we can enter. We have the position for this element is second, position for this element we have fourth, but for this element we don't assign any position, so it will return the error. So while sorry sorry while we are assigning any position of any element, then the number of positions as well as their corresponding value of the element must be equal. We are assigning three elements, then there will be 3 elements on the right hand side also. Otherwise, it will return error. Now we have the transpose of a vector in MATLAB. This is also very quite simple if you have a matrix or an array. Just in the case of transpose, the rows will be changes into column, you can see. And in the case of in the MATLAB, we can easily find out the transpose by using dash sign. You can see we have this is a vector. These commands which we write in the prompt sign in the red color, all these are the commands which we use in the command MATLAB command window. Okay, so you can easily use this command and see in the MATLAB. You can see I have v is equal to any vector. I am taking here 1, 3, 5, 7, 9. Okay, and when I will enter, this will return in this way. And when I am using v dash, v dash, so it will return the transpose of this vector. Very simple. V is equal to, we have this vector, and when we will take transpose of this v vector, and just we need to use only sign dash, and it will convert this row vector into column vector. Okay, and again when you will use transpose for this vector, see we are using here answer and it's a transpose. Okay, and see, so this is the transpose of a v vector. Okay, and again when we use transpose, it will return the same vector. You can see this value and this value both are same. Okay, okay, so now scalar multiplication is just a very quite simple. If we have a vector and we want to multiply with any scalar, this is just we have alpha into v1, v2, v3 up to vn, and if scalar is there, then each element of this scalar will be multiplied with alpha. You can see this example. We have a vector having the element 1, 2, 3, 4, 5, and we want to multiply with 2, where 2 is any scalar, and each element will be multiplied with the 2. Okay, and you can see here this is any vector. You can generate vector by using the column also. CLC, we can generate any vector using column. V is equal to, I have 1 to 9. Okay, and when I will enter, we have a vector or array. Okay, and also sometimes we need to customize this vector. Like if you are you need to customize. In the very first lecture, I explained all these things, and again, if you did not attend my first lecture, I will again explain this because this will be very helpful to manipulate the data. Okay, I am taking the vector from 0 to 5, but I need when I enter this vector 0 to 5, this will return this value. But if you will press upward arrow sign from the key, then and we can change, we can customize. I want to take the difference 0.5. Okay, in the previous by default the difference will be always 1. Okay, sometimes we need to customize this difference. That can be customized in this way. In the center, whenever you choose any value according to that, this will return the vector, and we can customize according to our choice. See, when I will enter, you can see the difference will be 0.5. Okay, and if you want to make more small, I am taking here 0 to the difference is 0.1. Okay, and When I will enter, you can see the difference between each point, each two consecutive point. We have only 0.1. Okay, these values are varies from and goes up to 1. Okay, so increment the middle value, this one, the middle value between two columns is increment, and also you can decrement like in this way. V2 is equal to I have a vector 9 a colon minus 2 and colon, then I have 2 and enter. So you can see here the decrement in is in 9 to 2 is 2. Okay, values are decreasing, and the last value is 3. Okay, because after that when we will subtract 2, we are subtracting 2 and the last value is here 2. So it will consider the second last element. Okay, so the difference up to 2 will be these. So in this way we can easily generate any vector. See, now manipulating on this, I have v is equal to this vector and I want to multiply. Then this is very quite simple. Multiply this vector with the scalar. So this will be 3. Then this is the sign of product and vector v. And when we will enter, you can see the element will be 3 times of these. This is the new vector. So this is the very simple scalar product of vector. Scalar multiplication. Okay. It is very quite simple. Now, vector addition and vector multiplication, this is also very important while manipulating any data in MATLAB. The first thing is the length of each vectors must be equal. Only then addition and subtraction will be possible, and also multiplication of two vectors. Okay, so you can see here this is the first vector and this is the third vector, and the length of both the two vectors are equal. And when we will add, then this will be element by element addition, and this will be equal to u1 plus v1, u2 plus v2, and un plus vn. And you can see here the same application in the MATLAB. U is a vector from 1 to 4. Okay, 4 elements are there, and v is again we have a vector, and these are from 5 to 8. Okay, and when you will do u plus v, so you can see 1 plus 5 we have 6, and so on. 2 plus 6 we have 8. Okay, and 4 plus 8 we have 12. Similarly, when you will choose a transpose, u is equal to transpose of 1 2 will be 1 2, rows will convert into column, and this is the second vector 3 4. Okay, and when you will do addition, u plus v, this will be return this value. So when you are entering addition, you want to operate addition and subtraction on two vectors, then the length of these vectors must be equal. Otherwise, it will be problem for the addition and for the subtraction. Now, matrices in MATLAB, how we can create matrix, basic operations, transpose, then we have concatenating matrices, predefined matrix, scalar and addition, multiplication, subtraction, multiplying matrices, identity matrix, inverse and determinant of matrix, matrix, power and exponential. Now we will these discuss one by one. So when you are going to enter or write a matrix in MATLAB, matrix is just the collection of vectors in the same length. Okay, so you can see here. If you have any question, you can put in the chat box and I will try to give your answer. Okay, I think all the things are very fine, and I will share this content on your email address. And also, I let you know that this content already has been updated on the link which already has been shared with all of you, and at the end I will also let you know where these content are available. If you are in the WhatsApp group, then I already share all these this presentation in your WhatsApp group also, and also you can find this content on the subscription of description of this YouTube channel where the session is live streaming. Okay, and I also share this link in your chat box at the end. See, see here. Okay. Yes. So now you can see if you want to enter a vector, how, sorry, matrix, how we can create a matrix in the MATLAB. This is very quite simple. A is equal to, we have, if we are entering a row, then the element of row are separated by comma or space. And for new row, we need to use semicolon. Okay, so when you will enter semicolon, then we have the next row will start, and these are the element of second row. Okay, and each element are separated by space, or we can use comma. And this is the third row, and the third row is also separated with the help of this sign semicolon. And when you will enter, we will have a matrix of 3 by 4 order, you can see. And when you will find the size of this matrix, we use size function for matrix. Okay, so this will return the size of matrix. See, in the MATLAB, I will give you only one example here, CLC, and I have A is equal to a matrix. So square brackets will be always used. Either you can use 1 plus 1 space 2 space 3. This is first row. And when you will enter here semicolon, the next row started, or you can use also comma 2 comma 3 comma 4, and semicolon, third row will start 4 comma 5 comma 6. Okay, and when you will enter, say A is equal to, we have this matrix, this is a matrix. Semicolon, when we will use at the end of the statement, this will always suppress the statement. Okay, so this is a very highly useful semicolon while we have long programming. When we have a number of sequence of commands, then we always use this semicolon. Okay, and if you will find the size of this matrix, you can see size of A. Okay, size of A, when you will enter, you can see this is the matrix of 3 by 3 order. This is the size. So first is the number of rows, and the second element is number of columns. So in this way, we can easily find out the size of matrix. Also, we can easily extract the element from any matrix. You can see if you want to access any element, the position is 2, 3. At this place, we have this matrix. Okay, we have this matrix, and we want to extract the element. Just 1 minute. We 1 minute, please. I need to connect device. Okay, so if you need to extract this any element, okay, this is very quite simple to extract. This is the element from first row and second column. So this can be extracted by using 1 and 2. So this will return this element. Okay, this is equal to 2. So in this way, we can easily extract any element, and you can see here, this is the Example, here is a two-third element has been extracted, and if you see in the MATLAB, we can easily extract the element. See, I want to extract the element from third row and second column. This is the second column, and when will I enter, you can see this is 5. You can see this is the corresponding element. Okay, third row and second column. In this way, we can easily extract any element from the matrix. Just assign the position of the matrix, corresponding element, which you want to extract from the matrix. Okay. These commands are also very useful and very important. I have to open one more. You can see these contents also. Okay. See here. Okay. See at this place we have in the first when we are using a colon n. Okay. This will return the reference to the element in all the rows of the column n of the matrix A. Okay, and if you are using this sign, these two, a n comma colon, this will return the columns of n row of the matrix A. And if you are using in this way, see in the MATLAB only, see in the MATLAB, it will be easy to explain all these things. CLC, I have this matrix, okay, and when I am using colon and comma 3. See here, I am entering here colon, comma and 3. And when I will enter, see what happen. You can see all the rows are there and third column. Okay, we have all the 3 rows from the third column. We enter here 3, it will return all the elements of third column. Third column means we have all the 3 rows, you can see. And if I will enter, like again, you can see I am entering here colon, comma and 1. It will return first column only. Okay, see, this is the first column. And if you want to extract only first row or third row, then you can do in this way. See, I want to extract only third row. Okay, and then use comma and colon and see what will be there. This was the matrix. You can see this was the matrix A, and when I enter this command, this is returning third row of the matrix A. You can see this is the A matrix. Okay, and when we enter this statement, it is returning third row. So when you are using before this comma, this will represent row, and after comma, this will represent column. Okay, so when you are using only column, it will consider all the elements. If you are using after the comma, it will consider all the column, and if you are using colon before the comma, then it will consider or extract all the rows. Sometimes we want to choose submatrix. Okay, see, I am writing here this statement. I need the element of second and third row. Okay, I am using second and third row, and the element of first and third column. Sorry, first and second column. Okay, first and second. Okay, see when I enter. You can see this is 2, 3, 4, 5. You can see this is 2, 3, 4, 5. These are the element of second row. These are the element of third row. Okay. Also, 2 and 4 are first column, 3 and 5 are second column. So these are first column and second column, and these are second row and third row. Okay, and when we enter this statement, it will extract or access the element of A corresponding to this input, which is the sub matrix of A. So in this way, we can easily extract a particular information from the set of data, and it is very quite simple to use. So you can see here, also this is the another way you can use also in this way. Sometimes you need first row and third row. Okay, first row and third row, then second column and fourth column. In that case, we have to access by using this statement. So there are many things, different ways to manipulate the matrix and operations. If you want to modify any value, see, we want to modify the value of this element. This element, the position third, fourth, the element of matrix in the third row and fourth column. Okay, so you can do in this way. When you will enter this command, this will replace the element. Okay, and you can see this is the matrix A. This is the matrix A, and we replace this element by using this statement. By using this statement, the element is now 12. Okay. Similarly, we can modify the first row if you want to modify first row. Okay, then you will use this command. But the thing is that you need to observe that how many columns are there, and according to that you can enter. Okay, see, we are entering here in the first column, in the first row, and these are the element of the first row. Okay, you can see here, but the new values will be 20 to 23. So these are four elements are replacing the first row of the matrix. So when you will enter this statement, and you can see that first row, and these are new element of the matrix. Okay. I think all the things are going very fine. Or you can put your question in the chat box also. I will try to give you answer. Okay. I am checking your queries also. See, transpose of a matrix. Okay, this is also very quite simple. In the same way, we can easily use the command, this one, and this will return the transpose of a matrix. Okay, You can see this is a matrix A, and this is the first row element, then we have second row element, then we have third row element. Just when you will enter, this will return this matrix. And when you will choose A transpose, okay, this will give us a new matrix. Rows will be transformed into columns. Here, see, I have this matrix A, and when you will use A transpose and enter, you can see that these rows are interchanged into column. Okay, very simple to use. Also, you can see that matrix computation in MATLAB is also very quite simple. If we have two different matrices, okay, if we have two different matrices, you can say this is we have A matrix, and when you will enter this is the third by third order matrix, okay, and this is the B matrix. This is also the order of 3 by 3 order. And when you will use the statement in this way, okay, so the element of A matrix will be appeared after the, sorry, element of B matrix will appear after A. You can see these elements are at this place. These are the element of A matrix, okay, and these are the element of B matrix. And this is very quite simple. Just use this statement. We need to use only this statement. A is equal to A and B. So at this place the element of A will appear, and at this place we have the element of B. And if you want to present below the A matrix, okay, then we will use this statement. A is equal to, we have A, use at its place semicolon, okay. See this example. When you will enter this statement, and you can see that this is the element of A matrix, and this is the element, these are the element of B matrix, and it is very quite simple. Predefined matrices in MATLAB, there are several functions which are inbuilt and we can directly use in the MATLAB. Zeros, when you will enter zeros of 3, this will generate a matrix of 3 by 3 order, and each element will be 0. If you want to enter identity matrix, then you need to apply this I function, okay. I function will return us identity matrix. So you can see at this place we have I, and we are entering here 3, value 3, and it we have the matrix which is identity of 3 order. If you will enter at this place 4, then we have identity matrix of 4 order, okay. And if you will enter, if you want to generate a matrix having each element are equal, okay, then you can use this ones function. This will return us the matrix of 3 by 3 order, okay. And magic function will always generate a matrix, uh, and there are some properties about the matrix you can see in the MATLAB. See in the MATLAB, CLC magic 3, okay, and enter. So you can see the elements are these, and when you will when you will find mean of A and S, okay, and C, mean is same. Or if you will mean of each row, this is the mean of each row, which is 5. It means sum of each row is equal Similarly, sum of each column will also equal. Similarly, the sum of diagonal element will also equal. You can see if you will add it 8 plus 5 plus 2, this is also 15. And if you will add 4 plus 5 plus 6, it is also 15. If you will add the first row or second row or third row, this will give us also again 15. And if you will add this element or second row or third row or any column, sum of any column, any row, any diagonal will always give us 15. Okay, so this is the magic. And if you are using A is equal to, you have magic 4, this will return this matrix, and it has also the same property which we see in the first one. Okay, so you can use magic matrix which will be automatically generated and having this type of property, okay, which I have explained in the previous example in this case. So in this case also, if you will find the mean, it will return the mean of each column. And see here the mean of each column, each value is same. You can see each values are same. Okay, so the sum of each row, sum of each column, sum of diagonal element, okay, all will be equal. So this is magic matrix in the MATLAB. Then scalar multiplication is quite simple. You can see A matrix and 3A will return each element of A matrix will be multiplied with 3. You can see very quite simple to use. Addition and subtraction having the same property. When we are going to addition and subtract two matrices, then the order of two matrices must be equal. Only then these operations are possible mathematically, and on the basis of mathematical operations we can do in the MATLAB also. Okay, so you can see this is A matrix, this is B matrix, and if you want to A plus B, and their addition will be equal to this one. So in the MATLAB you will enter the command like in this way: A is equal to 1 space 1 space 1 first row, 2 space 2 space 2, 3 space 3 space 3. Okay, this is A matrix, this is B matrix, and then do A plus B. It will return the addition of these two matrices, which is very quite simple. Then we have the product of matrix vector multiplication. Okay, you can see here is a matrix, and at this place we have vector, and we can easily do. And the operation of this one will be like in this way. I have less time, so I need to skip many informations. So you can see this can be easily done following in this way. When you will apply the operation in the MATLAB, you can do easily. Okay, and the product of matrices we have very simple. And when you are going to multiply two matrices, then the rule of matrix of product need to keep in mind while you are going to multiply, and it is very quite simple to multiply two matrices. This is A matrix, this is B matrix, and this product sign will be used for product of two matrices. Okay, very simple. And this is the identity matrix. We have already discussed about the identity matrix. If you want to find out a determinant of any matrix, okay, we will talk only MATLAB codes. So the function is determinant. Determinant is there, and by using this determinant function, we can easily find out the determinant of any matrix. I need to skip all these. Okay. If you want to simplify a system of equations, and this is very quite simple. You can see this is we have system of equations, and when we convert these system of equations into matrix, this will be appeared in this form, and this is A matrix, this is B matrix, and this is X vector containing X variable. Okay, so when we simplify all these and following the mathematical rule, you can see that X will be equal to A inverse into B. Okay, so the same process we need to apply. How we can find out the inverse of any matrix? Okay, so the inverse of any matrix is can be easily obtained by using this function. This function will always give us inverse of A, and when you will do a multiply inverse of A into B, this will give the vector X, and vector X has this element. So this is very quite simple to apply. See in the MATLAB. See in the MATLAB, these are the element we have matrix A. Okay, we can implement in the MATLAB. CLC, the element of A in the matrix are 2, 1, 3, 2, 1, 3. Okay, then second row, see in the MATLAB, element of second row are 1, minus 2, 5. Okay, 1, minus 2, 5. Then third row, and the element in the third row we have element in third row 3, 4, minus 2. 3, 4, minus 2. Okay, so this is matrix A, and matrix B is equal to, we have the elements of B are, what are the element of B? Element of B are minus 2, minus 13 and 15. Minus 2, minus 2, minus 12 and 15. Okay, sorry, minus 13 and 15. Minus 13 and 15, and suppress it by using semicolon, and see X will be equal to A inverse B. Okay, so okay, B statement is incorrect. I have to use a semicolon. Now it is fine. So X will be equal to inverse of A. Inverse of A. Okay, and then product B and enter. So you can see this is X vector. First is X element, second is Y element, third is Z element. These are the values of X, Y, Z, which are X equal to 1, Y equal to 2, Z equal to minus 2. So this is very quite simple approach to find out the solution of a system of equations by using MATLAB. Matrix power. Matrix power, we have this is A matrix, and we can use this sign exponent, and all the elements we can easily find out exponent by using this cape sign. Okay, so this will return the value of A matrix into A matrix into A matrix, product of three element. This is the value of A cube. Okay, and similarly if we have A cape 0. Okay, so this will if we have any matrix and its power is 0, exponent is 0, and after simplifying this will return we have an identity matrix. And if we are using exponential, okay, like in this way, e is equal to exponential 1, and if you are using e raised to power a. Okay, see here, we have a is equal to, we have this matrix, and if we are using exp, see, these are the exponential values. Okay, and similarly, we have example inbuilt function. There is this function. Okay, we can use, and then uh, this is the cape sign, this is the square root, this is the nth root. All these are inbuilt functions. Okay, eigenvalues and eigenvector, all of you are already familiar about eigenvalues and eigenvector, but there are numerous applications of eigenvalues and eigenvectors for stability analysis, vibrations analysis, atomic orbit, and facial recognitions. Numerous applications are there, and we can easily find out the eigenvalues and eigenvectors. Suppose if we have a matrix A, and we want to calculate eigenvalues and eigenvector. Okay, so this is very quite simple. We can write the code like in this way: v, d, and eigen of a. Eigenfunction will be used in the MATLAB. So this will return us the eigenvalues, as well as these are the eigenvalues and these are the eigenvectors. Okay, these are the collection of eigenvectors. This is first vector, this is the second vector, this is the third vector. This is v3, this is v2. Okay, this is v1. So in this way, we can easily directly find out the eigenvalues and eigenvector of the matrix. So along with the, I will give you this file also, and you can do many more applications. You can see in the first, just I need to reopen this file, I think. Okay, just 1 minute. Length function is there, then we have size function is there, we already discussed. Reshape, if you want to reshape any matrix, then you can use this function, and see at this place we have a is, this is a matrix, and by using reshape we can change the order of the matrix by using this one. So here a matrix and 3 by 2, here this matrix is of 3 by 3 order, and when we reshape by using this function, this matrix will be converted into 3 by 2 order. Okay, and you can see similarly we can find out the diagonal matrix if we have a v is equal to this vector, and we can easily convert into diagonal matrix. You can see diagonal function is used, and when we pass this v vector, and it will return diagonal matrix. Similarly, if we have any matrix and we want to find out, we want to convert it into diagonal vector. Okay, or we want to find out its diagonal, then it is very quite simple. Just use diagonal A, and it will give the elements of 1, 2, 3 of this diagonal element of this matrix. These already has been discussed. Okay, so I will provide you all this content, and this book already has been shared with you. You can find out in the live streaming. Okay, so I think all these are, how does MATLAB treat a situation in the rank of A and rank of B are different? Is there anyone who can send to me link? Yes, I let you know. Linear system of infinitely many solutions. Yes, according to your question, if the system is not consistent, then it will return the value NA or infinite solutions. So MATLAB automatically return the corresponding values. And further, if you want to go through more detail about this, you can find out in the MATLAB. It's also have a lot of information. So first, I would like to let you know where you can, if you are not in the WhatsApp group or you are not registered, then how you can find out the content which I have uploaded. You need just go to, I am sharing my desktop first with you, and then I let you know how you can find out this content. Okay. See, just go to YouTube. Okay. And you need to find out MathTech Thinking Foundation. Type here MathTech Thinking Foundation. Okay. And when you will enter, you get this is the website. Okay. And when you will enter, so all the details are available here. Just you need to go to playlist. Okay. So when you will go to playlist, this is the training session. This training session is ongoing. And when you will go to at the, this is the first day. Similarly, you can find out the for the second day and many more. See at this place. When you go to in the description, you can see at the end there are several links. At this place you can find out these are the feedback link for the first day, this is the feedback link for the second day, and this is the link where you can find the content which I have provided here. Okay, for the first day, second day, and today content also there. When you will click this link, see, click this link, this link will open, and when this link will open, you can find out, you will find all the contents. Book is there, and these are the content which I have shared with you. Okay, so this is the third day content. This presentation I discuss right now with you. Okay, and these are the plotting. These three contents are for 3 days. Okay, sorry, for the second day. And on the first day there was no content because all the thing we discussed on the MATLAB. So you need to go only the playlist, and there you can easily find all the sessions and the playlist. You can see this is the full list. Okay, first day is over, second day is over, and third day you can see it is now on live. This is live now. Okay, and in all the links, all the tutorial will be available here forever. You can visit here anytime, and all the content will be available forever. Okay, so feedback link for the today will be there after some time for day 1, day 2, day 3, and all the contents are there. You can easily find out, you can download, and if you have any question, you can submit your questions in the feedback, and we will discuss all these questions in the coming session. Okay. So next session will be held at this place, and this will be held on 13th February. So these are the content which we discuss here, and I think there are some questions. Time is now about to close this session. If you have some queries, you can submit your queries in the chat box, or you can submit your questions in the you can submit your questions in the feedback form. Okay, we there is a column to submit your questions, and we definitely consider your questions in the coming session. Thank you very much, all of you. Good night. We meet in the next session. And sorry, today due to some technical problem, you have to wait about half an hour. Okay. So I hope in the coming session there will be no such problem. And if you have any suggestion, you can submit in the feedback form. Thank you very much to attend this session. We meet in the next session, which will held on Sunday. Thank you. Sunday Expo. Thank you very much. Thank you all of you. Good night. Good night all of you.